Let us start with an introduction to blockchain. Blockchain is a distributed and decentralized ledger technology that allows data to be stored across several networks of computers in a way that ensures transparency, security, and immutability. Now let's come to the history of blockchain. The concept was introduced in 2008 by an individual or a group known as Satoshi Nakamoto, with the first application being Bitcoin, a decentralized cryptocurrency. The purpose of blockchain was initially designed to support digital currency but has since evolved to cover a wide range of applications beyond financial services. The key characteristics of blockchain are decentralization. Unlike traditional systems where a central authority like banks control the system, blockchain uses a network of nodes where each participant has a copy of the ledger. Once a book of data is added to the blockchain, it cannot be altered or deleted. This ensures transparency and security. Consensus mechanism. Blockchain networks use mechanisms like proof of work or proof of stake to validate and add transactions to the ledger. Now let us come to how blockchain works. Blocks. Each blocks contain a list of transactions. Once a block is filled with transactions, it is called cryptographically linked to the previous blocks, hence forming a blockchain. Nodes. These are individual computers participating in the network. Each node holds a complete copy of the blockchain and works together to validate new transactions. Mining. For some blockchains, miners solve complex mathematical puzzles and validate a block. This process consumes computational power and resources, as in Bitcoin's proof of work algorithm. Consensus algorithm. Proof of work or POW algorithm. Miners compete to solve a cryptographic puzzle, and the first one to succeed gets to add the block to the chain and hence receives a reward. Proof of stake or POS. Instead of mining, validators are chosen based on the numbers of coins they hold and are willing to stake as collateral. Now, let me talk about the applications of blockchain. While blockchain gained performance through cryptocurrencies, its use has expanded into many new industries. For example, financial services, cryptocurrency. Bitcoin, Ethereum, and other digital currencies allow peer to peer transactions without intermediaries like banks. Smart contracts. These are self executing contracts with the terms of the agreement directly written into the code. Ethereum is a key player in enabling smart contracts. Cross border payments. Blockchain allow for fast, secure, and cost-efficient international transaction, avoiding the delays and fees associated with the traditional banking systems. Supply chain management. Transparency. Blockchain can track the origin and movement of goods across the supply chain, ensuring transparency. Counterfeit prevention. By verifying the authenticity of products, blockchain helps in fighting counterfeit goods. Healthcare. Patient data security. Blockchain can provide secure and private sharing of medical records across healthcare providers. Tracking pharmaceuticals. It can also track the production and distribution of drugs, ensuring their authenticity and safety. Government and public sector, like voting systems. Blockchain can enable secure and transparent voting systems, reducing fraud and increasing voter confidence. Land registries. Some countries have started using blockchain to record land ownership, preventing disputes and frauds. Intellectual property. Content ownership. Artists and creators can register with works on blockchain, providing ownership and ensuring they are compensated for usage through smart contracts. Now, let me tell you about some of the challenges and limitations that blockchain faces. Despite its potential, blockchain faces several challenges. Let me explain. Scalability. Current blockchain systems, especially Bitcoin and Ethereum, struggle with scaling to handle large number of transactions. Energy consumption. Proof of work algorithm blockchains consume vast amount of energy, raising environmental concerns. This is one of the reasons for the shift towards proof of stake algorithm and other consensus algorithms. Regulations. Governments are still working on creating a legal framework for both blockchain and applications, especially around cryptocurrencies. Regulatory uncertainties can slow down the adoption. Many industries are still cautious about adopting blockchain due to its complexity and costs of integration and resistance from existing centralized systems. Now, let us come to the future of blockchains and solutions. Scalability solutions. Layer 2 solutions, sharding, and improvements in consensus algorithms are being developed to address scalability issues. Integration with AI and IoT. Combining blockchain with artificial intelligence and the IoT of things can enable more secure and autonomous systems in fields like logistics, healthcare, and smart cities. Decentralized finance or DeFi. Blockchain could revolutionize the financial systems by enabling decentralized lending, borrowing, and trading platforms. NFTs or non fungible tokens. NFTs allow for the representation of ownership in digital and physical assets, owning up new avenues for art, music, real estate, and more. Now, let me tell you what I think about blockchain's role in Web3 and decentralization. Blockchain plays a pivotal role in shaping the future of the internet known as Web3. Unlike the current version of the internet, Web 2.0, which is dominated by centralized entities such as big tech companies, Web3 is focused on decentralization, user control, and privacy. What is Web3? Web3 refers to the next phase of the internet that aims to decentralize control, giving power back to the users instead of centralizing entities like corporations. The core principle of Web3 is that users can own and control their data, identify an online presence without relying on intermediaries like Google, Facebook, and Amazon. Now, let us come to blockchain's role in Web3. Decentralized applications or DApps. Unlike traditional applications hosted on centralized servers, DApps operate on decentralized networks such as that powered by blockchain. These applications are not controlled by a single entity and the data is spread across multiple nodes, ensuring user ownership. Decentralized identity. Blockchain technology can enable users to have self-sovereign identities, meaning individuals can control and manage their digital identities without relying on centralized authorities. For example, they can use a blockchain-based digital ID for authentication across different platforms. Data ownership and privacy. Blockchain enables data to be stored in decentralized manner. Users can control who has access to the data and under what conditions, ensuring greater privacy compared to traditional internet platforms where data is often exploited by corporations. Content creation and monetization. Through blockchain and tokens based economies, content creators can directly monetize their work without intermediaries such as social media platforms or advertisers. They can get compensated fairly for their contributions and real ownership of their content. Decentralized autonomous organisms like DAOs. Definition: DAOs are organizations governed by smart contracts and consensus mechanisms on a blockchain, rather than centralized leadership. Every stakeholder has a say in the decision making process, promoting transparency and inclusivity. For example, a DAO might manage a decentralized project where every token holder can vote on decisions like funding, resource allocation, or partnerships. This removes the need for traditional organizational structures like boards or executives. Now, let me walk you through the trust and security in blockchain. Blockchain is often called trustless system because it does not require a trust in intermediaries or third parties. Instead, the technology ensures trust through various mechanisms, such as cryptography, public and private keys. Blockchain uses cryptography to secure transactions and ensure that only authorized parties can access information. Public keys are shared with others, while private keys are kept secret to sign and authorize transactions. Hash functions. Each block on the chain is linked through cryptographic hashes. A hash is a fixed size output generated from input data, and it is unique for each set of data. Even the slightest change in the data will completely different hash, making tampering evident. Consensus mechanisms. Proof of work. As mentioned earlier, miners solve complicated cryptographic puzzles to validate transactions. This ensures that the majority of the network has to agree on the state of the blockchain, maintaining security. Proof of stake. Validators in a POS system must take their cryptocurrency as collateral. This financial investment incentivizes validators to act honestly as they stand to lose their stake if they attempt to tamper with the network. Transparency and auditability. Open ledger. Blockchain's distributed nature ensures that all participants can access the same information, making it highly transparent. This also allows for real time auditing, reducing the risk of fraud and manipulation. Traceability. Every transaction is permanently recorded in the blockchain, making it easy to trace the flow of assets and data. This is particularly useful in areas like supply chain management or financial auditing. Blockchain technology has proven to be a disruptive force, changing how we think about money, contracts, and data security. Its decentralizing nature can lead to greater transparency and trust, but there are still hurdles to overcome before it can reach its full potential. Now, let me tell you how blockchain concepts help other industries. Blockchain technology holds the potential to revolutionize many industries by enhancing transparency, security, and efficiency. Let's explore how different sectors could benefit from blockchain concepts, using specific examples. First, supply chain management. The current problem in supply chain management is to imagine a luxury good or company that faces issues with counterfeit products infiltrating the market. This fake damages their brand and reputation and hurt sales. So the solution by blockchain can be by using blockchain to track each step of the production and distribution process. Every item can have a unique identifier on the blockchain which is updated at each stage: manufacturing, shipping, retail. For example, if a company produces high-end watches, embeds a blockchain-based digital certificate onto every watch, customers can verify its authenticity by scanning a QR code linked to the blockchain record. This enhances the traceability and prevents fraud. Walmart is using blockchain to track the origins of food products, allowing it to trace the journey from farm to store shelves, making it easier to identify and recall contaminated items during a food safety crisis. Number 2. Healthcare. A patient visits multiple hospitals and doctors, but their medical history is scattered across different systems. This results in inefficiencies, duplicated results, and risk in treatment because the medical data is fragmented. A blockchain-based healthcare provider can platform can provide patients control of their medical records, allowing them to share access with any doctor or hospital instantly. This ensures data integrity and privacy, as only authorized parties can access the information. For example, if a cancer patient needs to visit a specialist, they can use their blockchain-based health record grant and specialist temporary access to their complete medical history, preventing unnecessary tests and speeding up diagnosis. Companies like Medical Chain are developing blockchain-based platforms that allow patients to store their medical data securely and remotely and control who has access to them. Number 3. Finance and banking. International money transfers are expensive and slow. For example, if someone in India wants to send money to a family member in US, it can take days and involve high fees, especially to traditional banking or wire services. Blockchain-based financial services can facilitate faster, cheaper cross-border payments. Use blockchain and transactions could be settled within minutes, at a fraction of the cost since the middleman bank payment processes are removed. For instance, cryptocurrencies like Ripple aim to revolutionize international payments by settling transactions almost instantly, no matter the country or currency involved. Ripple is already partnered with major banks, including Santander, to offer faster international remittances. Number 4. Real estate. The process of buying or selling property is slow and involves multiple intermediaries like brokers, lawyers, banks, who charge hefty fees and add to the complexity. By using blockchain for smart contracts, the buying and selling of process can be automated and simplified. For example, a person buying a house can have the transaction completely or entirely on the blockchain. Once payment is confirmed, the ownership is automatically transferred to the buyer without the need of a broker or lawyer to mediate. This increases efficiency and reduces transaction costs. Propi is a platform that facilitates real estate transactions using blockchain technology. They've already facilitated the sale of properties using smart contracts in several countries. Number 5. Voting systems. Many countries still rely on traditional voting systems that are vulnerable to tampering, fraud, or inefficiency, leading to questions about election integrity. A blockchain-based voting system could allow citizens to cast their votes securely and transparently from anywhere. For example, in a nation election, voters can use a blockchain-based enabled platform to register their vote, which can be instantly verified and recorded on the blockchain. The system could ensure transparency, immutability, meaning no votes can be altered or deleted, and results can be verified by anyone, reducing fraud risks. Estonia is a pioneer in e-governance and has a trial blockchain-based voting for local elections, showing the potential for secure and digital voting. Number 6. Intellectual property and content creation. Artists and creators often struggle to prove ownership of their work or receive fair compensation when their content is used without permission. Artists can use blockchain to timestamp and register their content creations, providing their ownership. For example, a musician can upload their latest song to a blockchain based platform that automatically assigns a digital token representing their ownership. This could be linked to a smart contract that automatically royalty payments whether the song is streamed or used in a commercial setting. This ensures fair compensation and ownership rights for creators. Platforms like Audius are leveraging blockchains to give musicians control over their music, distribution, and earnings, cutting out the need for intermediaries like record labels. Number 7. Energy sector. In traditional energy markets, consumers have limited control over their energy usage, and the entire system is often managed by large corporations or centralized utilities. Blockchain can facilitate a peer-to-peer energy trading where households that generate excess energy through solar panels can sell it directly to their neighbors without going through a central agency or company. For instance, imagine a neighborhood where each home has a solar panel and a blockchain-based smart meter. Households can sell the surplus energy to others in real time using a blockchain marketplace, reducing the energy costs and allowing for decentralized energy management. In Australia, Power Ledger is using blockchain technology to enable peer to peer energy trading, allowing individuals to buy and sell electricity generated from renewable resources. Number 8. Insurance. Filing insurance claims is often a lengthy and inefficient process that involves manual verification and extensive paperwork, leading to delays in payouts. Insurance companies can use smart contracts to automate the claims for process. For example, in a crop insurance, if a farmer purchases an insurance policy on the blockchain and droughts occur, satellite data could automatically trigger a smart contract and pay out the claim, without the farmer needing to file any paperwork. This ensures faster and automated payments, increased trust in the insurance system. AXA Insurance launched a blockchain-based insurance product called Fizzy that automates compensates and travelers if their flight is delayed. In conclusion, I would like to say that across various industries, blockchain technology can bring transformative changes by enhancing transparency, security, and efficiency. From eliminating intermediaries in financial transactions to automating insurance claims and ensuring the authenticity of goods in supply chains, the applications are vast and growing. Blockchain's ability to disrupt traditional systems and introduce decentralized alternatives makes it a key technology for the future. Thank you.